Well, hi everyone. As was just said, I'm going to be talking about the cloud. This clinic has gone through a lot of iterations. I do a lot of work in the cloud. I like work a lot with, big data sets and big cloud data. Been enmeshed in that for some time now. But as we developed this clinic, we really went over the last really 2 months, or kind of around in circles about what exactly aspects of the cloud would be most relevant and helpful for this group. And so, in the end, we decided that for this clinic, I'm going to be talking about cloud and the way that moving to the cloud changes our workflow, or to take advantage of the cloud, how we will want to change our workflows and how we think about data and computing. So I'm going to keep this at a really high level. And then next week, when I get talk about cloud computing, we're going to have a clinic for those who are interested in cloud workstations, which is kind of like a real small segment of this. All right. So, why cloud? Why are we talking about this? Well, really, in a way, it comes down to this, that we are migrating all our data to the cloud by, within, this year. And then also our on-premise computing resources. And this means like our high performance computing, not like taking away our computers or our laptops, our high performance computing that we might have had on premise, say at your science center or office. That's going to be, or planned to be, moved also into cloud infrastructure. So today I'm going to talk about two aspects of the cloud data and cloud computing. And when I say cloud, what does that mean? It really means that computing and data services that operate remotely. They're not either like your computer or a computer that's physically at your center. And it's not actually a single like computer. It's more like a resource. We'll talk about that in a moment. I mean, it is like a computer, but it's not like a single like computer out there that's in somebody else's office. So cloud data and cloud computing, we already interact with these all the time, and we'll be, interacting with these through our browser and on our phones. Whenever you look at Google Photos, you're interacting with cloud data. When you stream movies, you're streaming cloud data. Cloud computing, when you get onto Google Drive, you edit a doc, you are using cloud computing. However, in the context today, when I'm talking about computing, I will be talking about really scientific computing. Okay, let's talk about cloud data. So, what does cloud data mean? And I want to talk about this in the context of the shift of NOAA fisheries data to the cloud. This is a little different than if you were to Google what is cloud data. You would be getting something that's really about these last two bullet points. And that's relevant for some of you, but really much more relevant is this first bullet. And it's really about moving data away from being in siloed, sort of like either on your computer or behind a firewall at your center or office, in places where it's really restricted access, moving that into these shared locations so that, and so it's not on your personal computer or like on a hard drive or at a server that only people at your center can access. So it's moving everything into these resources that are managed by a cloud data provider like Google or Oracle. Okay, so I'm going to be talking, or I am going to talk about that. But I think for us, when we're thinking about moving to the cloud, that's the big feature that we are thinking about, moving away from having siloed data. Um, but I do want to mention what like these other type of cloud data. So often when people say cloud data, they are talking about a particular kind of cloud infrastructure, and it's not Google Drive. These would typically be cloud data buckets. And this is cloud data infrastructure that it's optimized for very fast access and access by a whole lot of people. So like the reason you can stream a movie and a million other people can stream it at the same time is that it's on this special infrastructure that is optimized for that. And you can think of it for our purposes, the way we use data, these kind of cloud buckets. Typically, we're using them where we need like a hard drive in the sky. We need to be sharing big data with our colleagues. Cloud native data, you might have heard about that. It's not quite the same thing. It is using the cloud infrastructure for sure, but it has an extra part, was that is a particular format that allows you to interact with the data in chunks. This is very important for those of you who are working with big data. So that's like acoustics, genetics, video data, lots of imagery data, or Earth observation data, satellite data, huge gridded databases, or modeled ocean modeled data. That's what I work with. For those of us who are working with that kind of data, we're concerned about these kind of cloud optimized formats. All right. Okay, but let's talk about the first one. And so, as we're moving into these shared environments, putting our data up into the cloud, it's a changing of a mindset about our data. So we're changing from my data, and I know what this data is, I'm the only one using it, or it's your team also, right? Small group of people, to shared data. And there's some changes that come with that. So like in the old way, right, you have this data scattered across, say, individual hard drives or servers. And when you're moving to this, shared data, the data is residing in more central locations. There's one version of that. And it's important that you have this strategy shift. You need to think about how to make that data findable and how to make self-describing data. So self-describing becomes very important now as we're moving our data to the cloud, because we're moving from my data to shared data. Somebody else might want to use this. Another change that happens is that we start moving away from downloading data sets onto our own computer, or if we're working with huge data sets, mailing around, hard drives. Instead, we are streaming that data. So the data out in the cloud is kind of like the hard drive in the sky, and we access that data. We don't download a whole bunch of individual copies. We have one copy that we are all accessing. Another change is moving from our IT having to manage things locally to having a service provider managing that for us. And so that means that our staff don't have to spend so much time thinking about maintaining things. That's one thing, but also that our systems can scale as they need to. Okay. So let's think about like some of the changes. Like, what does that mean? Like, as you're moving data into these shared locations. And I just want to talk about like Google Drive, because realistically, that is going to be the place where a fair bit of our data is going to go, at least in the near term. And as you're doing that, there's again the shift about from my data, I understand it, to, hey, I want to make the data understandable to others and understandable to machines. because the data becomes more valuable when it's no longer just kind of like unstructured data, like we're just kind of throwing the data into the garage, but we add some extra information. And now this powerful, you can kind of think of it like the really intelligent search system. That's kind of what Gemini is. Gemini can start to make sense of our data when we add some extra information. So it can start understanding the data and making connections. And it's not just for Gemini or just any AI. It's also helpful for people. So here I put are just some really standard kinds of like simple structure that are like recommended. So things like thinking about using the folders naming as metadata. So you have, raw, process, derived, release. That's an example. It then starts to be clear what this is. Using the file names descriptively. Again, thinking about like there's some algorithm searching it and trying to understand your data and giving it a little bit of help so it can understand it. Adding a README to each folder is super helpful. That's super helpful for the people, in the future, other people who would be looking at this also. And a nice thing I think, about Gemini is, because it is generative, like you can create your first README in the style you want, and then use Gemini to help you create the next ones. You can say, hey, look at all the files in here, create a new one in this structure. I've found things like that speed me up a lot. So, these are just some simple ideas of, the ways that you might provide some extra information about the data. And it's all about like starting to making this data more valuable rather than just kind of like, throwing it out there. Okay, so that's like general information that we're putting into Drive, and we want to be able to like search that and make sense of that in the future. There's a kind of a subset of that of what I would call our data sets. So it's not like everything that we put into Drive by the long shot is what would be called a data set. But there are things that are data sets, and we want to identify those. And when I say we here, it's actually you. I think the teams who are working with the data, they are the ones who will be able to identify if this is a data set. So what is a data set? So it's something that you can kind of define what it is. It's intended for reuse, and reuse has value and something you want to share. It's not something ephemeral and exploratory, so not like notebooks, one-off exploratory scripts, not something like that. Here are some examples that would fit like our context. So finalized data sets for analyses, model outputs, integral to reports, data supporting published research or reports that we produce, key data delivered, those kind of things. So the first step of is identifying, yeah, okay, I've got this is a data set. And now we're thinking about how we're going to make this valuable. And step one, once you've identified, yeah, I'm going to call that a data set, is then giving it an internal identifier. Because once you have that, you've kind of like given it like a catalog card and say, yeah, this is a thing. And you get an internal identifier, and now you have like a catalog card, and you can put other information on that. So you point to, where is that data? Is that data published, for example? And then these four here are some really common, like just really simple things that you can say about this data set that make it much more valuable. But the first key thing is like giving it that internal identifier. This isn't a DOI. This isn't about publishing. This is internal. This is for us. Just say, hey, this is our little card. This here is a data set. And at NMFS, we have import that creates that for us. And import will also take these things for you. So once you define what a data set is, you then give it a little identifier. And once you have that, you can add other things. And for example, the next step, it kind of depends what that data set is. It may be that formal publishing, like in the clinic, you learned how to do this with Zenodo. But we also, for our official data sets, would be publishing those with NCEI. That's the NOAA data repository. And that would get you like a formal DOI and it's archived for forever and ever. That might be an option for your data set. But in any case, once you have that little card, you can put those things on it. Okay, so those are things to think about as like moving data to the cloud. It's not just getting it into the shared location. It's changing your mindset that, hey, this is an asset. And once I have an asset, I need to add a little more information to make that really valuable. Okay, and now I want to move on and switch gears and talk about computing in the cloud. As I mentioned, we're moving our on-premise computing into the cloud. It's a process. This doesn't mean taking away your computer. It means giving you access to high-performance computing using virtual machines. Okay, so this won't apply for all of you, but for those it does apply to, it's a really a great new thing. So this would be people who, let's say you do really long-term simulations that might take a month or a week. And if you could get access to a virtual machine with more power, you could get that simulation done faster. Or you just want to have it running on your laptop the whole time. Or you need to be working with, big data, so you need access to some cloud buckets, that sort of thing. All right, so we're really fortunate at NOAA Fisheries. There's been a pilot going on last year to give us access to Google workstations. We are leaving the pilot phase. A number of people on this call, well, I was involved with that. I think some other people on the call may have also been involved with the pilot. But we're moving out of the pilot into the beta phase and rolling this out, more access to this. And we are having a demo run by Molly Stevens and John Peak and Alex. I forget Alex's last name. So the three of them will be showing you how to spin up these workstations and what you can do with them, how you can connect them to Google Buckets and this sort of thing, and how to do stuff. So go ahead and in the agenda, you can add that to your calendar. And Steph, if you could put that link also in the chat so people can sign up there. Okay. So what is a virtual computer? It is like a computer. Like I said, it's like a computer that's provisioned on remote infrastructure. Some ways that us at NOAA Fisheries might be working on these. Now we have Google Workstations. We also have the NMFS OpenScapes Jupyter Hub. It's a different interface for the user. Same idea, generating a machine that's set up for us in the cloud that we work on. We'll be doing our hack hours again starting February if you want to play around on those. Today we'll do a demo with Colab. You'll get to see that. I'm almost done, Julie. Okay. So why would you use cloud computing rather than just doing things on your own computer? So I think like this box over here is one of the primary reasons is you need more power than you have on your laptop or your computer. This way you get the power for the task at hand. And then when you're done with that task at hand, you release the machine. So you only use it for when you need it and you get as much as you need at the moment. Okay, so it's this, you're being able to scale. That's really important. Another really important aspect is that Traditionally, everyone had to install everything on their computers. That's fine if that's kind of a simple setup. But once we start getting these more complicated compute environments, this really takes a lot of people's time, and that's a waste of people's time to have to do that. Much better to go into an environment that's already set up for you and that's going to work. Um, and then the last one here, again, working with big data doesn't apply to all of you, but for those it does apply to, it's important to, you can save a lot of money if you can get your compute next to the data. So in the same um, cloud computing infrastructure. Okay, I am going to stop there. We'll come back to this when we do the demo. I think we're going to do a little reflection or getting some questions.
Great. Thanks, Eli. Great timing as well. Um, so we are on page 7, and we're going to have a little bit of reflection time before we ask Eli questions and see the demo and discuss a bit more. And we're really interested in hearing your reactions and ideas so that we can pass this along with NIPS Open Science to leadership to help address some of these issues or ideas that you have. So there's 3 prompts here on page 7, and we'll have about 5 minutes. I'll set a timer. The first is, how do these cloud strategies resonate with you and your work? Another is, what questions do you have about cloud strategies? And a third is, what opportunities or challenges do you see with cloud strategies? So maybe, Eli, will you stop screen sharing and I'll set a timer, and we'll go from there. Thanks. Okay, I'm seeing writing slowing down a little bit. I wonder if we take the next minute to review other people's and any plus ones or reflect a little bit further. Okay. Well, this is great to see these challenges, questions, ideas, reactions. Um, Eli, how are you? Would you like to continue just with the demo and then we'll discuss afterwards? Does that seem best?
Yeah,
Okay, super.
yeah,
Carry on.
yeah. Thanks everyone for your comments there. We'll discuss them after we take a little break and play around a little bit. All right. Um, okay, so thank you. Oh, okay, here we go. Back there. Okay, great. So what we're going to do next is going to take a few minutes and jump on and play around with some of these ideas. We're going to play around with data in buckets, in a Google bucket, a big data set, and we're going to use Google Colab to spin up a machine for us. This is not Google Workstation. Totally different. This is a free service from Google. But we decided to use this because everyone will be able to jump on and play around. But it's the same idea. Somewhere off in the a computer is spun up for us to play around with some data and code. And we're going to, in this demo, we're going to work with some data in a Google bucket, two data sets. One is a very large data set of stream vectors. It's a data set that I put into the NOAA Open Data Dissemination. Uh, if you are unaware of this, this is an asset that we have access to. Um, so if you have public data sets you want to make available, each of the centers has these buckets. You can go talk with the person. I believe it should be someone in your data governance group who would be able to give you access. That's how I got access. And so we'll be looking at some data sets that I've put in for my division. You can go to your center, poke around. There's lots of different data that people have put into these buckets, and it doesn't cost you anything. It's free, but it has to be public. So we'll be working with this. These are daily means of stream flow, daily stream flow from across all the western states. We'll plot that. And then we'll also plot some data sets from some research I'm doing on chlorophyll depth profile, global chlorophyll depth profiles in the ocean. These are very big data sets, and you'll get to see how this new cloud infrastructure and cloud data infrastructure allows you to work with really big data sets fast. Okay, So this is the URL. I'll stick it in. And so what it is, I've got, this is Python, but you won't have to write any code. But I can use Colab here. It's a free service and point it to a file in GitHub and it'll just open it for me. You can use it for yours too. We use it for training all the time, teaching. All right, so if you hop onto here, what do you see? We're going to be playing. You can click here if you want, learn about this particular data set, the Streamflow data set. And so first what we're going to do is, so in Colab, you roll over a code box like this, and you'll see a little arrow, and you can click that. So click that. As that go, they run anyway. As it goes, I'll tell you what's happening. So it's taking some data that's in a Google bucket. This is a very large file of all this Streamflow data. And it is grabbing that. It didn't download it. It just loaded it into memory, and it loaded only the bit that I asked for into memory. So even though this is massive, the way it worked, it only loaded what I needed into memory. And you can see it took 5 seconds and it plotted all these stream lines out for me. Let's do a bigger example. So this will take a little longer. Roll over this one. We're going to do a big one, which is east of San Francisco. So we are now going to access even more data. And I should say I'm on a tiny little free virtual machine, but it's so efficient at accessing this really big data, it doesn't blow anything up. So I'm going to go click that. So again, what it's doing, it's accessing this very large data set and it's only loading what it needed into memory. And then here you can see it took 4 seconds and boom, made a plot. If you happen to know the HUC, that's a watershed numbering system, you can play around and plot your own watersheds. All right, so now we're going to do something a little different and access some different data. So this is an even larger data set. This is a 2 terabyte data set. And this is this global daily depth profiles of chlorophyll in the ocean. You can read about the background here if you want. And this was an example where I used cloud computing a lot. I needed to access NASA data in the cloud. And then I'm training data on a different data set of BioArgo profile data and running boosted regression trees using some NASA hyperspectral data to train the model. And that took a really long time. So I ran it on 20 different virtual machines at once. So it would run overnight rather than a week. Processed all that. And then I put the result into Google Node in what's called a ZAR format. It's a very efficient format for this kind of gridded data. So let's go ahead and plot something from that. Before we do that, so right under it says open data set, run this code here because you need to install a couple packages that Google didn't provide for us. It actually, Google by default provides a lot of packages, but it didn't happen to provide these two. But that's okay. I can just install them. You see, it went fast. And now we can make a plot. So let's go here. We'll just run this. So what's going on here? So this is a 2 terabyte data set. It's a gridded data set. Again, I said it's a ZAR. If you use NetCDFs, it's a different format. This is kind of like that, but more efficient. It opened it all up and we can scroll down and look at that. It made a cool plot. So again, this is kind of amazing. We accessed a really big data set, but we only downloaded the bit that we needed. And you saw it happened really fast. Okay, so let's do something I think even more a little bit amazing. So we're going to take this little box right here. Oh, actually, I want to say one aside thing here. One of the amazing things now with AI helping us code is you can make really cool visualizations so much easier. So I didn't know how to, I mean, I've made plots like this, I guess, but I couldn't remember how to do it. But I didn't have to. I just told Jim and I described the plot that I wanted and it gave me the code to make this. So yeah, much better visualizations now. Okay, so what we're going to do, we're going to take this little box here, and we're going to now look at the daily data for, I guess, like 16 months, and we're going to take monthly means of and figure out where the depth of the chlorophyll, the peak chlorophyll is in the water column for each of the months. So before Well, go ahead and go here and click that. Doesn't take that long. So this would have taken a long time before, a decade ago, if I tried to do something like this would probably blow up my RAM for one, because just it would have to load all the data in. But now with these new formats, these chunked formats, it doesn't have to load all the data in. I think I'm working on a 2 GB RAM virtual machine. It's so efficient in how it chunks the data that you can see it did this in 20 seconds and processed massive amounts of data. And there we go. There is the monthly mean in that little box. It's showing something that we know about chlorophyll, how there's these seasonal cycles of where the chlorophyll appears in the water column. So this is 50 meters. This is close to the surface. It's up by the surface. And then in the winter months, the peak is lower down. So that's seasonal cycle. All right. Um,
Great.
there we go. You got to play with some big data and do some cool computations. Hope that was fun.